In today's note, we're going to continue to focus on acute triangle trigonometry, again with the focus on cosine law, specifically for solving for angles. So in the last lesson we looked at cosine law for solving for side lengths, and now we're going to look at solving for angles. The same kind of applies when we're dealing with acute triangles. If you do not have a full pair and half a pair, then you can use the cosine law to solve. Again, the two rules, or the two laws that we're going to be looking at for solving non-right angled triangles is sine law and cosine law. Remember, sine law was the full pair and half a pair. And if we do not have that, then we can use cosine law. Cosine law is a little bit different for solving for angles. Unfortunately, sine law, it was just the same formula, and you could just rearrange. However, with cosine law, it is a little bit different. It's still the same formula at its core. However, we've just rearranged it to help us isolate for our angle. So we have three different variations for the three different angles because it does kind of require us to plug things into a specific spot. So our cosine law formula generally is cosine C equals a squared plus b squared minus c squared divided by 2ab. And it's the same variation or same general formula if we're solving for b and a. The only difference is the angle that we're looking for and the side that we're subtracting. So again, the key thing is it's the exact same formula. However, we just want to make sure that when we're plugging in information, this angle that we're looking for, its corresponding side is being subtracted when we square everything. Other than that, the two other sides, doesn't really matter where we put them. The angle or the order doesn't matter because when we add two terms, order doesn't matter, and when we multiply two things, the order doesn't matter. But the key thing is that our angle that we're looking for and its corresponding side is in the subtraction spot, as we see here highlighted. Again, remember that the capital letters represent your angles, the lowercase letters represent your sides in the formula, and to identify when we need to use cosine law to find our missing angle, it's actually fairly easy because when we have all three sides, or we need to have all three sides in order to solve for a missing angle using the cosine law. So you need to have all three sides, or side, side, side. So in this first example, we're going to use cosine law to find our missing angle. We can see that we have all three sides and one missing angle. So I don't have enough information to use sine law. So now what I'm going to do is use cosine law. Because I'm looking for angle A, I know that it has to be then cosine A equals, and then it should be b squared plus c squared minus a squared. So again, that angle A and the subtraction has to be kind of paired up. So we see cosine A, we're subtracting side A, everything's paired up, divided by 2bc. Again, because we have the formula, and you can look back at your notes, you don't have to worry about this too much. It's more of an issue when we come to triangles that aren't using A, B, and C as labels. Once I write out my formula, I'm going to fill in my information. So cosine A, can't fill in anything in for that. If I wanted to, I can make that cosine x. B squared, so 22 squared, plus 20 squared minus 21 squared, all divided by 2 times 22 times 20. Again, to make it a little bit easier on myself, especially if I'm going back and double checking my answers, I'm going to simplify the top first and then simplify the bottom. If you're comfortable, you could do it all in one step, but again, this one, especially because we're dividing, you want to make sure that your bed mass is done correctly. So I would suggest doing it in two separate parts. It's not too much of an extra calculation. Once we simplify, we get cosine x equals 443 divided by 880. Now, even though our numbers are pretty big, this should look fairly similar to something we've done before. And it should look similar to when we used our cosine ratio when dealing with right-angled triangles. And essentially, this is basically going to be the same steps. To get x by itself, I need to move the cosine over, and when I move it over, it becomes the inverse. So cosine -1 of this fraction is going to give me my angle. So cosine -1, 443 divided by 880. You could simplify that on your own or previously if you wanted to. And we should get roughly 60 degrees. So again, key thing to note here, when we're going through and solving for an angle, we've seen this now in cosine law, we've seen it in sine law, and we've seen it in our trig ratios. Whenever we solve for an angle, we have to do the inverse, and that should be the last step. Or in terms of the right angle trig, it's the only step. So again, we've done the inverse, we found our angle. One key thing that you want to be aware of, or if you want to check, this fraction that we get, or this ratio, should, or not should, it is, so it's always less than 1. So that ratio should always be less than 1 in order for this to work. If you find something where it's not less than 1, then chances are you've made a mistake or there's an error somewhere in your calculations. So that's just another way that you can check that. So I'm going to move on to B. So again, same idea. You have a missing angle. You have all three sides. So you're going to use the cosine law to solve for the missing angle. It is labeled A, B, and C, so hopefully you can use or pick out the correct formula from going back up to make it a little bit easier. If not, just you can relabel the vertices and then just make sure you label the sides correctly based off of that to make it the exact same as the previous one we just did. However, since we do have the notes and you are allowed to use them, I do recommend trying to use or keep the labeling the same and you pick the right formula above. But again, I'm going to suggest that you pause the video and then we'll go through and try this on your own and we'll come back with the full solutions. So coming back to this question, we should have picked the formula cosine B equals a squared plus c squared minus b squared, all divided by 2ac. Again, the key thing is that the angle we're looking for, B, is paired up with the side, or its corresponding side is paired up with the one we're subtracting. So those are the two positions where it should be. A and C are other ones. Doesn't really matter, again, because the order doesn't matter. So going through and solving, making sure we plugged our sides into the correct spots, simplifying the top first, then simplifying the bottom just to make it a little bit easier and a way to go back and check. We go to our last step where we do the inverse of cosine, and the inverse should give us an angle of 68 degrees. And again, we can double check here. This is less than 1. So we know we're on the right track with our calculations, or our denominator is larger than the numerator. So that's a good thing. It's a good check. So again, that's how we solve for a missing angle using the cosine law. Again, with cosine law, I think the calculations are fairly straightforward. The hardest part is going to be making sure you've used the correct formula, or you've entered the information in the correct spots. Moving on to our last example, we're going to look at a word problem that's going to require us to apply a couple pieces or a few different concepts. So the bases in a baseball diamond are 90 feet apart. So I'm going to go through this step by step. So they're 90 feet apart. So when we go through and label 90 feet apart, so each white line is 90 feet from base to base. A player picks up a ground ball 11 feet from third base. So 11 feet from third base along the line from second to third. So that means along here, player picks up the ball and they're 11 feet from third base. We want to determine, actually let's just put a little dot, that's our player. We want to determine the angle that is formed between first base, the player's position, and home plate. So actually let me highlight that. So what we're looking for is the angle from the player's position, from first base, the player's position, and home plate. So if I draw my triangle in blue there, that's what I'm looking for. I'm looking for this angle down here. We'll call it X. So I have one side. I don't have any other information for angles. So the only thing that I can really do is somehow figure out the two other sides. And the nice thing about the baseball diamond is that we have 90-degree angles from the bases or when they join. So I can make new triangles or right angle triangles here. So there's one with a 90-degree angle. I have two sides. And here's a second one with a 90-degree angle. And now the full side isn't 90 here, but we know that from this dot to third is 11. So that means from the dot to second is going to be 90 minus 11, or 79 feet. Because again, that whole distance is 90. We know part of it is 11. The other half, or other part, needs to be 79. So we now have a couple of triangles to work with. We have one right angle triangle here. This is the third base and home plate one. So it's 11 and 90. And I can find this missing side, which is shared with the triangle that we're dealing with. And I have another right angle triangle here with second and first. 79, 90, and again we're looking for that side which is shared to our overall triangle, which we know 90. We're looking for this angle, but these two sides we're going to find shortly. So looking at our first triangle, all we have to do to find that missing side length, even though we could, or we can't use trig because we don't have any other angles, we can use our Pythagorean theorem. So let's just call it a squared equals 90 squared plus 11 squared. A squared equals 8,221. Again, we have to square root that. So A equals basically 91. So that is one side length for our triangle. So I'm going to go back in and put 91 in as our side length. For the next triangle, I'll just call it B. B squared is our unknown, equals 90 squared plus 79 squared. So B squared equals 14,341. To get B by itself, I need to square root that. B equals basically 120 rounded. So I can replace that in our triangle now. Now I have enough information to solve for my missing angle. I have two missing, or I have all three sides, so I just have to make sure that I label them correctly. Since we've already labeled A and B, so 91 was technically A, let's call this A. 120 was B, so let's call that big B, and we'll have little c. So we'll just label it that way. Again, you can label it however you want, as long as you put the things into the correct spots, and we'll talk about what I mean by that. So we're looking for angle A in the way we've labeled it. So that means our formula is going to be cosine A equals B squared plus C squared minus A squared, all divided by 2BC. Again, remember with cosine law, the angle we're looking for has to be paired up with the term that we're subtracting. So cosine A subtracting A squared. So they're paired up. So again, that's what I mean by it doesn't matter how you label it as long as these two are paired up. And then again, it can't be just in the formula. It has to be when you plug in the information. So cosine of, call it x now, unknown, is equal to b squared, which based off of my triangle and my labeling is 120, plus c squared, which is 90, or 90 squared, minus a squared, which is 91, so minus 91 squared, times 2 times b, or 2 times 120, times 90. Again, I'm going to simplify the top first. I am dealing with some larger numbers now, so it will benefit me to kind of do it in two parts. So 120 squared plus 90 squared minus 91 squared equals 14,219 divided by 2 times 120 times 90, 21,600. Again, it's good to see that the denominator is larger than the numerator, because that means that my ratio or my fraction is going to be less than 1. To get x by itself, I'm doing the inverse now. The inverse of cosine, when I move it over, it becomes the inverse, and I should know that anytime I'm trying to find an angle, the last step after I've simplified everything should be the angle. So 14,219 divided by 21,600. And when I simplify all this, cosine -1, 14,219 divided by 21,600, I should get an angle of 49 degrees. So the angle between from first base to the player and first base and home plate is 49 degrees. Again, make sure that you are in degree mode when you're doing these calculations. So this one required us to do a little bit more. It required us to use Pythagorean Theorem to help us find our missing sides, which is okay because it does let us review that. We haven't reviewed that maybe in a little bit. We've been focusing mostly on some of the other questions required us to use the angle theorem of all angles in a triangle add up to 180. So this was a little bit of a different quick calculation that we could do to find other sides. So it's something that you should be aware of. Don't forget about that. So again, the main thing from this note, though, is just understanding how the formula changes for cosine law when we're looking for an angle, and just making sure that when we're writing out those formulas, the angle that we're looking for is paired up with the term we're subtracting. So that side, or that little letter, should be paired up with that angle, or we should be subtracting its corresponding side in the formula. Other than that, again, making sure that you take it step by step, simplify when needed, try not to do it all at once if you're not comfortable with your calculator, and make sure you're in degree mode. One last thing before we go. Today's code word is lamp. Again, today's code word is lamp. So that's it for the cosine law. We've looked at how to find an angle today, or in this lesson. In the previous lesson, we've looked at solving for a side. So we have finished looking at cosine law and overall specifically acute triangle trigonometry. Because it was cosine law and sine law, those are the two laws that we're going to be looking at when dealing with acute triangles. And if you need to, again, please feel free to go back, look at the previous lessons just to review it if you need it.